Hello everyone. Today we're going to be looking at some problems relating to heat transfer. So that means we're going to be using this formula here, Q equals mc delta T, or this here, Q equals mc multiplied the final temperature minus the initial temperature. They're the same thing, okay? We'll talk about this more in a second, but for the moment, I just want to talk about specific heat capacity a little bit. So specific heat capacity is the C in this equation. Okay. So what is it? It's the amount of heat required to raise the temperature of a substance by 1 unit. So the amount of energy or heat required to raise the temperature by 1 degrees Celsius or 1 degree Kelvin. Okay. Different materials have different specific heat capacities, which means they require different amounts of energy to change temperature. For example, water has a high specific heat capacity, so it takes a lot of energy to heat it up, while other substances heat up more quickly. Okay, so we can actually rearrange the equation up here to make specific heat capacity the subject, and then we see that specific heat capacity is equal to Q over m delta T. Okay, so that's specific heat capacity. Now let's talk about this equation here. So for this one, Q, I haven't actually written it down, I'll write it down now. Q is equal to the heat energy, right? So it's the heat or thermal energy, and that's going to be measured in joules. So the amount of heat energy either gained or lost in a system is equal to the mass in kilograms multiplied by the specific heat capacity. Now that's actually measured in joules per kilogram, and multiply that by the change in temperature as well, delta T. Now this delta T, this one here, the change in temperature is also the same as final minus initial temperature. So sometimes you might be asked to find the initial temperature of a substance. In that case, you just rearrange the equation to make Ti the subject. Okay, now let's go through an example. So we have a look at this question here. How much energy is required to heat 2 kilograms of water from 20 to 30 degrees? So step 1, I'm going to write down the formula that we're going to use. And then we go through what the question has given us. So the question has given us the mass, is 2 kilograms, and it's given us the change in temperature. So the change in temperature is 10 degrees Celsius. And the specific heat capacity of water will usually be given to us, but it's a good one to remember regardless. And that is 4180 joules per kilogram per Kelvin or degrees Celsius. That's the unit for it there. And if we then use the formula, so we put these values into the formula here, let's see what we get. 3,600 joules. So it requires that much energy to heat the water from 20 to 30 degrees Celsius. And we could then write this in scientific notation if the question wanted us to, which is 8.36 times 10 to the 4 joules. Okay. Alright, hopefully that makes some sense.